Hello everyone. Today we're gonna show you the example how to determine whether the series converge absolutely, converge conditionally, or diverges. Okay, let us review the concept. If summation an converges, then summation an also converges, and then we say that summation an converge absolutely. And if summation of absolute value of an diverges and summation an converges, then we say that summation an converge conditionally. So we see that this we talk about summation an, so that converge conditionally. Okay, if summation uh, an diverges, yeah, of course summation an diverges. Okay, let's see the first example. Okay, we consider this example. So let's say this is our an. This is our an. Okay, so let's consider the summation of absolute value of an. What is this one? Okay, when we talk about absolute value, of this. Okay, so absolute value of negative 1 raised to n plus 1. That's just 1 because this is change the sign, plus 1, negative 1, plus 1, negative 1. So the absolute value is 1. Okay, so for the absolute value of an, we just have this summation n over 2n to the third plus 1. Okay, this one converge or diverge. Okay, how do we do this? Do you remember the limit comparison test? So we're gonna compare this with let's say bn. Okay, so bn is let's say n over, so remember we get it from the leading term n over 2n to the third. Well, but since the two, when you talk about the series whether converge or diverge, we don't need the number here, so let's remove number 2 here. Okay, and then so your bn is 1 over n square, and we see that summation bn here is summation 1 over n square, converge or diverge. This converge by p series with p equal to 2, which is greater than 1. That's why this series converges. Okay, so what's the limit comparison test? For limit comparison test, we need to check it with this one, limit of this one divide by bn, and this is our bn. Okay, or in other words, we just flip over that one. Okay, you cannot remember, please go back and review the limit comparison test. Okay, and approach to infinity, which see that we have a limit n approach infinity of n to the third divided by 2n to the third plus 1. Okay, so we see that numerator and denominator the same degree, right? So to find the limit, there are many ways to find the limit, but I try to tell you the shortcut here. Since the degree is the same, So to find the limit, just take the leading coefficient, divide by the leading coefficient. Numerator, the leading coefficient is 1. So the limit is equal to 1/2, which is not equal to 0. So this means that by the limit comparison test, this means this series and this series has the same convergence. If this one converge, this means that this also converges. Okay, that's why we know that this series converges by the limit comparison test. Okay, so we know this converge. Okay, now since we know that summation of absolute value of an converges, summation of the series of the absolute value of an converges, then summation of an converge absolutely. Okay, that's why we know that this series converge absolutely. Okay, that's the first example.